Next, we're going to learn about the inverse of our trig functions, sine, cosine, and tangent. So we've got a graph of our sine function here. Remember, for a function to have an inverse that is also a function, it needs to pass the horizontal line test. With our sine function, we obviously fail the horizontal line test. So the way that we fix that so that our sine function has an inverse that's also a function is we restrict part of the domain. You can see this pink section right here. This is the restricted domain for our inverse function. What this does is it gives us the entire range of sine values from -1 to 1, and it passes the horizontal line test. So when you use your calculator to do sine inverse, it will only give you the values between -π/2 and +π/2 if you're in radians, or if you're in degrees, from -90 degrees to +90 degrees. So you can see that written as our range for the inverse function. The domain is the input of the inverse function. Because the sine function will only give you answers from -1 to 1, those are the only values you can put into the inverse function. We have the same problem with the cosine function. It does not pass the horizontal line test, so we restrict part of the domain because our cosine function does not start and stop in the same place our sine function does. This inverse has a different range. It goes from 0 to pi if you are in radians, or from 0 to 180 degrees. But it does have the same domain. Both sine and cosine will only give you outputs from -1 to 1, so those are the only values you can put into the inverse function. Finally, we'll take a look at our tangent function. Same problem, fails the vertical line test, so we have to restrict our domain with these asymptotes between -π/2 and +π/2. Notice our set notation has parentheses. That means the -π/2 and the +π/2 are not actually output values for our inverse function because they're asymptotes of our original function. The domain, however, is all real numbers. You can get any ratio out as an answer for your tangent function, so you can put any value into the tangent inverse function. Now that we have all of that clear as day, let's take a look at how this works by evaluating our different inverse functions. For our sine function, we put angles into the sine function and we get ratios out of the sine function. For the inverse, it switches. We put ratios into the inverse function and we get angles out of the function. The first angle of rotation we're looking for is in radians, and we need to know where the sine function is -1/2. Setting up our unit circle, the range for the sine inverse function is from -π/2 to +π/2. Those are the only values that our sine inverse function will give us. Sine is negative in the fourth quadrant, but I still use reference angles because I don't have the whole unit circle memorized. I just memorize the first quadrant. Sine goes 1/2, √2/2, √3/2. So here at π/6 is where sine would be +1/2. So at -π/6, sine would be -1/2. So the sine inverse of -1/2 is -π/6. The second example, it's a different notation for the inverse function. Arcsine, arccosine, and arctangent all mean the same thing as inverse. Sine inverse of 2. So we're thinking, where on the unit circle is sine equal to 2? Well, it's a unit circle. The maximum value that the unit circle gives us is 1. So this is outside the range of sine, which means it's outside the domain of the inverse function. You can't put a value into the inverse function that's larger than 1 or smaller than -1. So this one has no solution. Another way to think about this is SOHCAHTOA. So here's our theta. Sine is opposite over hypotenuse. The hypotenuse is the longest side of the right triangle. So anytime you set up that opposite over hypotenuse, it will give you a fraction that is smaller than 1. It's between 0 and 1. Once we move that ratio to the unit circle, we can also get negative values, but they will still be between 0 and negative 1. That's why you can't get an output greater than 1 for the sine, and why you can't put a value larger than 1 into the sine inverse. All right, example 2, we're looking at arc cosine or cosine inverse. This time we're giving our answer in degrees. Remember, cosine being the x value is positive in the first quadrant and negative in the second quadrant. So we're going from 0 to 180 degrees to think about where our cosine is root 2 over 2. Of course, cosine is positive in the first quadrant, and the root 2 over 2 is the one right in the middle at 45 degrees. Now we're thinking about radians, looking at where cosine is 1/2. I'm going to think reference angle first, and then we'll flip it into the second quadrant. Cosine goes 3, 2, 1. So cosine is 1/2 at pi over 3. Flipping that into the second quadrant, it would be negative at 2 pi over 3. Now let's take a look at our tangent function. Sine inverse and tangent inverse have the same range because tangent is positive in the first quadrant and negative in the fourth quadrant, and it has asymptotes at negative pi over 2 and positive pi over 2. So even though tangent is also negative in the second quadrant, there's that asymptote between the positive and the negative, so it doesn't make sense to use that for our range for tangent inverse. So both sine inverse and tangent inverse are the first and fourth quadrant, negative pi over 2 to positive pi over 2. Cosine inverse is the one with the different range because cosine is positive in both the first and the fourth quadrant, so we can't use that for our inverse range. It has to be from 0 to pi. All right, tangent inverse is a little bit trickier to evaluate because we don't have that one memorized. We memorized sine and cosine, but we haven't memorized the tangent values. So you can either memorize the tangent values or you can think about it logically. When we look at the ordered pairs for the 3 angles that we have, cosine goes 3, 2, 1, and sine is backwards from that, 1, 2, 3. Remember, tangent is sine over cosine. Looking at the one for pi over 3, the one up top, if we do sine over cosine, the root 3 over 2 times the reciprocal of 1/2, we get root 3. Those 2's cancel. Of course, at the 45 degrees, sine over cosine is 1. They equal each other. At the pi over 6, 1/2, and multiplied by the reciprocal, we have to rationalize. We end up with root 3 over 3. Again, you can either look at the ordered pairs and think logically about the tangent function. We've got root 3, 1, and root 3 over 3. Which one do you need to rationalize? That's the one that's root 3 over 3. So in our case, in radians, our arctan of root 3 over 3 is pi over 6. Finally, tangent inverse of 0. Well, where is tangent 0? Tangent will be 0 when sine is 0. Tangent is undefined when cosine is 0. So tangent is undefined at the negative pi over 2 and positive pi over 2. And tangent is 0 when sine is 0 at 0 degrees. Two U-try questions. Use your knowledge of the unit circle to figure out the angles of rotation that give you the ratio for each of these two questions.